So this lesson we are going to do arithmetic on polynomials. Our objective will be to add, to subtract, and to multiply polynomials. We won't be doing division today, merely adding, subtracting, and multiplying. We'll also learn to recognize and to use special product patterns. So let's start with adding and subtracting polynomials. How do we add and subtract them? Remember, adding and subtracting are very much related. Subtraction is just adding the opposite, so we can lump these together in terms of procedure. When we add and subtract polynomials, it's merely adding and subtracting the like terms. It's very similar to what we've done in the past. Say, for example, we have this initial polynomial, and let's subtract it with a second polynomial right here. We're going to subtract it, so we need to, in this case, we're going to turn this negative sign and change all of these signs here like this as our first step. So I change this to a plus sign and then negate each of these different terms here. So now I'm just dealing with addition. Then let's identify our like terms. I like to sometimes start with the highest order term. So I scan across this and I find an x cubed term. I underline it. I'm going to mark it so I know that I've already dealt with it. Part of this task is organizational. The next thing I do is I look for my next term. I scan across. I see an x squared term. And that's the only one. There's no other x squared term. Scan across again. I see an x term here. No other x term. And then lastly, I'm left with a constant term here, a constant term here. I add these together. Let's look at another example. In this other example, we have a polynomial, and the like terms are slightly different. Instead of just being of a single type of variable, we have an x squared term, we have an xy term, we have a y squared term. So we need to identify which ones are the same when we add them together. And in this case, there's no particular order. I'm just going to start from the left-hand side and look for terms across. So I'll start with the x squared term, and I notice there's two of them. There's one right here, there's one right here. Next term, I just scan across here, negative 2xy. I'm looking for my other xy terms. I find another one right here. Then I go to my y squared term, and then finally my constant term at the very end. So very simple process. I think the key that I like to do, if I'm doing it very carefully, is I'm underlining the like terms in a certain way. It allows me to even go back and double check my work. It allows me to make sure I've covered every single term, and it allows me to double check that I've done it right if I wanted to review my work later on. Okay, let's look at multiplication. How do we multiply polynomials? The method is really like FOIL on steroids. We take every term of the first polynomial and we multiply it by every term of the second polynomial. You can kind of think of it as super distribution. So let's look at one example here. We have our two polynomials that we're multiplying together. And the first step is we take the first term of the polynomial and multiply it by every single term of the other polynomial, as you see here. We do the same for the next term. Our next term is 3. We take that term and multiply it against every term of the second polynomial, and then we just add all the like terms together, and we have our final solution. Let's look at another example. This is a little bit more involved, but not too much. I have a 3-term polynomial times a 3-term polynomial. So I take the first term in blue, multiply it against every element. I do the same with the next term, multiply it against every element. Last term, the third term, multiply it against every element. I'll just blast out the solution here. And as I wrote these out, I tried to write them out in an organized way. You might recognize that you can do this and make it easier when you add them together. I noticed here that I was able to, I saw a pattern as I was multiplying these out, so I wrote it kind of nicely in this vertical fashion here. You don't need to do this. This is just an organizational tip if you find that this works for you. So I multiplied my x squared term, my 3x term, my 2 term, and then added them all up to get the final answer below. The last thing we're going to cover is special product patterns. Special product patterns allow us to save some time. We've seen some of these before. We have what we call sum and difference. And another name that we had for this was the difference of perfect squares. We have a plus b, a minus b. We have our sum, we have our difference, and it's equal to the difference of perfect squares. We have binomial squares. We called these perfect square trinomials previously. And these have this pattern. We've seen this pattern before. So this is a very useful pattern to know. And then this is the new one. We haven't covered this one before. It's our cubic binomial, binomial cubed. If I have a plus b cubed, or if I have a minus b cubed, I have a special pattern for these as well. I can multiply them all out. I can use the previous steps to multiply polynomials out that we covered just the other page. But if I can remember this special pattern, it saves me some time. And you notice the difference between the two is very much just the plus and minus sign between a couple of the terms. So let's look at some examples of how we would use this. So if I had two polynomials, I recognize here, this is like my a minus b and a plus b. I can rewrite this as a difference of perfect squares. Here's my a squared term minus my b squared term, and I could simplify it. I have another example here. A binomial square. This is like my a minus b squared. I can write it out like this using my pattern. This is like my a squared minus 2ab plus b squared. And then lastly, let's see how it applies to my binomial cubed case. So again, I just plug it into this pattern that I would like you to memorize. It's very useful again. It saves you time. So in this case, I'm using this pattern up here. I have my a cubed term right here, my 3a squared b term right here, my 3ab squared term over here, and then lastly I have my b cubed term right there. So this completes our lesson. Learn and study these special product patterns.